Hey, Alex, Eric, how you guys doing?
Hey, James.
And
Yeah, very well, thanks. How are you?
Doing well. Well, thanks for joining me today. And hello, everyone, and welcome to episode 75 of the Invest with James West podcast series. I'm pleased to have with me today the co-founder and CEO of Qube Technologies, Alex MacGregor, and the company's COO, Eric Wynn, whose mission is to help companies, particularly those in the energy industry, combat fugitive methane emissions. New regulations and ESG standards are making reliable emissions monitoring a business imperative, and of course, not just for the upstream oil and gas industry. In order to curb fugitive emissions, governments are mandating leak detection and repair programs, such as the US EPA's Method 21, the Canadian Directive 060, and European Method EN 15446. We'll get into some of these in more details a bit later. Alex is Qube's co-founder and CEO. He's worked as a professional engineer in the oil and gas industry for over 10 years, including 8 years in energy technology. He was formerly the Canadian sales and distribution manager for Ambient and previously worked as a consultant for Cerna in their Canadian, Australian, and US offices. Alex holds a Bachelor of Applied Science and Geological Engineering from the University of British Columbia. And Eric oversees Qube's operations and supports product development and sales. In his previous role with Bain & Company, he served as a manager in their London and Seattle offices. And prior to Bain, Eric was a special engineer at Talisman and Cerna, where he worked on oil and gas projects in North America and Australia. Eric holds an MBA from the London Business School and a mechanical engineering degree from the University of British Columbia. Gentlemen, thanks for joining me today.
Yeah, great to
thanks
be
for
here,
having
James.
us.
Great. Well, before we get into the technology and, of course, some of the major themes that are driving your growth, can you give us the elevator pitch for Qube? What's the problem you're solving for?
Yeah, sure. Methane or natural gas is a very harmful gas, greenhouse gas. Over a 20-year period, it's over 80 times more potent than carbon dioxide, which everybody knows. Not only is it really important to reduce methane emissions in our efforts to fight against climate change, but it also makes a lot of financial sense to reduce methane since what you don't emit to the atmosphere can be actually sold onto the market. The problem is that there's a lot of things in the industry that can emit methane. And if you're only intermittently checking for leaks in a manual process, chances are likely you'll miss things or catch things at a much later stage. That's why it's important to continuously monitor for emissions and not only address leaks when they occur, but prioritize the biggest emitters first. At Qube, we aim to be the lowest cost continuous emissions monitoring system in the market so that we can give our customers the information they need to reduce emissions as cost effectively as possible.
Right. Well, the world is adapting to the issue of methane emissions. Some of this is through, of course, the push for energy transition, some through new renewable gases and fuels, and of course, carbon tax and credit markets are developing. Could you potentially rank which of these are having the biggest impact on your customer conversations and perhaps highlight what your customers are doing to adapt?
Yeah, no problem. So what we really see in the market is a bit of a spectrum. So what we see is some operators want to do the bare minimum as it pertains to the current regulations. However, we're fortunate enough to work with a number of operators that are taking a different approach. And they see kind of the regulatory environment becoming more stringent. They see capital markets increasing scrutiny on emissions disclosures, and they hear their customers or end users demanding cleaner products. And ultimately, they want to do the right thing when it comes not only to reducing emissions, but also waste. So there's a lot of drivers in this space. So these things include, doing the right thing by the environment, the regulator, and the market. And really, the emergence of things like certified gas is really pushing a lot of adoption in this space.
Okay, interesting. And so what about the regulations? I know I mentioned a couple in the intro. Can you describe how these are designed, if they are effective, and what change is this leading to for your customers?
Yeah, for sure. I think regulations are a pretty strong driver in this market. Current regulations around methane do exist, but I think as Alex mentioned, they're also evolving. I think most regulations are around this idea of leak detection and repair programs, or LDAR, where operators are mandated to inspect site leaks periodically, inspect sites for leaks periodically and then fix them within a certain time when they're found. The intention of this is great, but it does present a few inefficiencies. First, most regulations only allow the use for intermittent technologies like optical gas imaging cameras. Think of these as your 1990s style cameras that look at heat differences in the gas. So if you're only inspecting sites once a year or once a quarter, chances are likely that you're going to miss emissions or catch leaks much later than you would want. Another inefficiency that we see is that you have to repair any leaks that you find. Now, that's not necessarily a bad thing from an environmental standpoint, but it's not maybe the most effective use of capital. We've heard stories from some of our customers where they spent tens of thousands of dollars fixing $100 worth of gas. Most studies show that the majority of leaks come from a very small number of sites. Wouldn't it be better if, from both the operator and from the environmental standpoint, if you can focus on your biggest emitters first and spend the capital more efficiently? That's kind of what we aim to do here at Qube. If you can deploy continuous monitoring across your asset base, you'll know in real time what your emissions profile is on any given site 365 days a year. You can then use that data to prioritize which site you're targeting for remediation first.
Right. Okay. And now, what's the current technology option, and what makes the Axon product superior?
Yeah, good question. So there's really a range of technologies out there. So anything from satellites to planes to handheld devices, and continuous monitoring companies like ourselves. And all of these different technologies kind of have a different use case and kind of place in the market in different detection limits where they can be more or less effective. In terms of our product and why we think it's a really effective way to solve the problem is, one, it's continuous, and two, we've spent a lot of time really developing our sensor technology to get a low-cost product that's very sensitive. So we can detect a methane leak of 0.1 kilograms per hour, which, to give a bit of context, is much smaller than a barbecue turned on at 100 meters. So we provide a really nice balance of cost effectiveness, but also sensitivity.
Right.
Additionally, the next piece really is the analytics behind the technology. So, data is great, but the end user, which is typically an operator at an oil and gas company, has to be able to make sense of the data we're collecting. So we spent a lot of effort developing our quantification algorithms. So taking those gas concentration readings and converting them to a volume, as well as our localization algorithms. So using the environmental data we collect, so things like wind speed and wind direction, in conjunction with the methane readings to say where the leak is at an operating facility.
Okay. And maybe we can dig a little further on detection. Obviously, the first step. You mentioned some metrics around the tool and how powerful it is, but could you compare that maybe to other detection methods and compare how the Axon product is much more powerful?
Yeah, I think with most data related tools, only as powerful as you make that data useful, right? And I think from a detection standpoint, because we're able to detect things at a much lower rate, just to give a comparison, like most aerial-based surveys are an order of magnitude higher in terms of minimum detection limits. Satellites are much higher than that. But we'd be for the first to admit that there's no silver bullet solution for all sites here. You need a technology stack, and we think an important part of that stack is continuous monitoring, especially on the ground. You can use satellites to find that really massive emitters in areas where you don't have regulated or strong regulations on. But from a detection standpoint, because you're monitoring continuously, you're able to detect things much quicker. I think the analogy we like to use is, imagine if you have a house and instead of using a fire alarm, you send in the fire department to check for leaks check for fires 3 times per year. If they find a fire, great, they'll put it out. But if they don't, they may not find something until the next inspection. That's effectively what's happening with a lot of the regulations today. With our system, you can find things, really small leaks, that you may not necessarily want to do anything about, but you want to certainly track it in case it becomes bigger. You certainly want to quantify it as part of your totalized emissions profile. And with our detection, we've been able to help our clients not only find fugitive emission sources like thief hatches stuck open and address those a lot quicker, but also opportunities to improve vented emissions, which is a big source of most emissions on a site.
Interesting. Okay. Well, so on the measurement side, I know you mentioned it's continuous. I'm assuming you also are harnessing some AI and particularly maybe some machine learning capabilities as well. Is that correct?
Yeah, that's right. And so we have a couple of different algorithms. What we're doing today is, I'd say, primarily a physics-based algorithm to quantify the emissions. And this works really well. We provide a leak location as well as a quantified volume, as long as the gas is hitting the sensors. So when you think about how these sensors get deployed at an operating facility, you're typically creating a perimeter around the facility. You're placing devices based on the prevailing wind load data in locations that are most likely to measure methane. But what can happen is, you'll get a leak and the wind will move around and it won't be hitting the sensor all of the time. So what we're doing with AI and ML is really trying to make inferences on what's happening at a site when our sensors aren't measuring methane. The idea there is that we'll ultimately get to a better answer from a quantification standpoint.
Okay. And then how do you help with the reduction process?
Yeah, so I think the first step, we just help alert the operators when there's an emission event on a site. We can set alert thresholds based on like a rate or a duration. And then using our system, you can figure out where it's coming from, whether it's a vented source where you want to monitor for it, but not necessarily fix because it's not broken, or whether it's a potential fugitive emission where there's something actually broken. If there is a repair that has been done, one of the things that our system does, because we're continuous monitoring, is we can see if the fix has been done appropriately. So in many case studies where you see a pretty high baseline emission because there's a fugitive emission, as soon as the fix is done, you can actually see a tailing off of that emissions profile on that site. We're seeing a lot of kind of increased demand for this to be using as an operational tool. And one of the things that we're building is workflows, and how do you actually capture all the things that you're doing on a site from a repair standpoint? You have the data that shows you have an emission. Now you have the data that shows that you fixed emissions. Can you actually capture all the actions that you took to get from step A to B?
Okay. And then what is the support process like after you've installed and then scaled your system?
Yeah, so I mean, we pride ourselves kind of on our customer support. Many people at the company have come from kind of a energy technology background where we've actively kind of worked with operators in more of a support customer success type role. But for us, in terms of the process itself, we typically, have a pretty robust pilot process where there's a lot of engagement. And then once we've scaled, we've created internal reports just to analyze kind of the health of our fleet. So just looking at, what the uptime is of the devices, what the level of charge is, because all of our devices are battery and solar powered. And if there's kind of anything anomalous happening with our calibration algorithm. And so if we do see those issues, we're notified in more or less real time, and we're able to proactively address those with all of our customers.
Okay. And how do you ensure the reliability of both the system and the measurements?
Yeah, I think it all starts kind of at the design phases. We've had prototypes out in the market since early 2017, and a lot of that is focused on reliability. I think we've designed a product to work in a bunch of different environments, but it's a single kind of design. That's how we get the cost down, by mass producing a single design. But it needs to work in a bunch of different kind of temperatures and humidity levels. The same device that we deploy in northern Canada in the middle of winter, where you don't get a lot of sun and it's minus 50 degrees, is the same device that we deploy in Texas in the heat of the summer. I think Alex mentioned that we proactively look at kind of anomalous events from all our sensor data. Are we getting enough recharge? Do we get adequate data signals? Do we get adequate data transmission rates? And we'll set off flags or alerts internally that help us manage, okay, we're not getting adequate recharge. Why could this be? Then we have a team of support staff that actually look at this. And most of the time, a lot of things that we can fix remotely using over-the-air updates. Other times, we'll work with the operators to ensure that the data is continuous. A common thing we see in North America in the wintertime is you'll get a bit of snow accumulation on the solar panels, so your recharge rate isn't as high. So, we flag that. Our devices can last quite a few days without power or without solar recharge, but we just ask the operator, hey, next time you're on site, just give those solar panels a brush, and we'll usually see the solar recharge rate kick back up.
Okay, interesting. Are there any case studies you'd like to share?
Yeah, sure. So, we have a bunch of case studies that are related to early detection of leaks. So things like a thief hatch stuck open, or a dump valve kind of stuck, which we catch early, the operator fixes. A more interesting one kind of that we've done with a large operator in the US recently was our technology can measure more than just methane. So we actually measure up to 5 different gases. In this case, we paired a methane and a CO sensor, and we're able to detect incomplete combustion coming from a burner system based off of kind of parallel methane and CO concentrations. And what's really interesting about this is that the operator was following up with an OGI camera to find the source of the emissions, but because the burner system was running so warm, you can't actually see the gas with an OGI camera. So our system was able to correctly identify this incomplete combustion event, and they had a burner company come out and optimize the system, and it led to about a 90% reduction in emissions at this pad. And they've since started to scale that process across one of their assets.
Wow. Well, I think we've got a good grasp of the technology now, but what about customers? Who's the ideal Qube customer, and can you share any well-known names with us?
Yeah, I mean, I think the ideal customer is someone who just wants to use our data to better understand their emissions and take action. We've been very fortunate to work with some great operators in Canada, the US, and around the world. From I think a couple that we can talk publicly and that have announced are large multinationals like ConocoPhillips, to more kind of private focused companies like TRP Energy that we're very excited to be working with.
Okay.
Yeah. We're also working with ARC Resources in Canada. They're a fairly large client up here, and then we're part of Cheniere's QMRV project.
Okay. Interesting. And then how do you approach customer engagement? Does it start with a pilot program and then scale? How does the process work?
Yeah, that's exactly right. So we typically start out with a 3 to 6 month pilot at a handful of facilities, and the process is really kind of teaching the operator how they can use the technology to reduce emissions. So we typically start out with a bit of a baseline where we understand what the operating profile of the facility looks like from an emission standpoint, and then we would essentially set up notifications to help operators find larger leaks first, and then it's a bit of a continuous improvement effort to, once you've got the low-hanging fruit, to continue to reduce emissions.
Okay. And what's the life cycle of a project? I'm assuming it's probably the same life cycle of the asset that you're monitoring. Is that fair?
Yeah, that's correct. I mean, I think, as long as that asset is producing, and even, we're doing some projects right now where we're looking at abandoned facilities or abandoned wells to look at, have those abandoned processes been followed correctly? Are there potential emissions coming from those non-producing assets as well? I think, our system is meant to be continuous monitoring as long as you are, if that site is live. Our system is actually quite modular by basis as well. So if there are certain things that kind of break down over time, let's say the anemometer, we don't have to swap out the entire system. You can actually just switch out that specific piece. So it's a lot more cost effectively to maintain monitoring across a prolonged life of the asset.
And then how many axons would be on a typical project? I know that may be hard to talk about a typical project, but just can you give us some idea of how many different monitoring devices?
Yeah, for your typical multi-well battery, you'd be looking at 3 to 4 devices. We are monitoring larger facilities, like some midstream companies are having us monitoring kind of like large gas plants, and that might require as many as 12 to 15 devices. With each deployment that we do, we create a pre-deployment plan where we look at wind data from the nearest municipal airport, and then essentially look at the equipment on site, figure out where gas is most likely to disperse to, and then create kind of a unique plan for each facility, which includes the number of devices as well as the optimal placement.
Right. And then how do you manage the scaling process, or how are you managing the scaling process, both the manufacturing side and then the deployment side as you guys grow?
Yeah, it's definitely been an interesting challenge given COVID and everything, but I think we managed it quite well. We now have a dedicated manufacturing facility here in Canada where we can produce over 1,000 devices per month. And then we ship those devices for installations, and the installations are typically either done by us or the customer, or like a third-party E&I installer. We spent quite a bit of time revamping our installation process, and the idea is that we can, when you take a device out of the box, within 30 minutes, you should have that device up and running and send you emissions data. We're talking about thousands of assets that could be deployed. So even if you save 1 minute or 2 minutes per device in terms of installation, that could add up to be a lot of time for the operator and for us.
Right. And how global is the business now?
Yeah, so obviously methane isn't a North American specific problem. It's a global problem, and we've developed a solution to help solve that problem. So the same device that we've deployed in kind of -40 in Canada, we've deployed at plus 45, plus 50 in the Permian. We've recently kind of scaled beyond North America. So we have deployments now in Australia, Indonesia, and the Middle East, and we're also starting to work on a couple of different industries. So we're working with a waste treatment company and having some conversations around monitoring some feedlots.
Okay. And how does Qube, if you do, act as an intermediary between an operator, a regulator, and the certifiers?
Yeah, great question. I think, given the evolving nature of some of these regulations and the emergence of things like certified gas, we really try to help the operators make the case for continuous monitoring. I think the idea is that, because you're detecting things much quicker, you can prove that from a cost-effective basis that you can actually not only meet current regulations but exceed them in many cases. And if you do exceed them, then you're probably doing a lot better than your peers, and within the market, and potentially getting a premium on that from a certified gas perspective. I think tactically what this actually means is that we help with things like regulatory applications, designing the LDAR program, modeling out the emission reduction potential, and then doing the compliance reporting. I think one thing that we found is that the things that a regulator would typically ask for when it comes to continuous monitoring data is very similar to what a certifier asks for. So we kind of fit quite nicely in between both of those, and helping the operators get the right information, present that information in a way that can help not only the regulator understand what we're doing here with continuous monitoring, but prove to the certifiers that the emission reductions are what you're seeing.
Yeah, and I'll add a bit on to that. We're lucky to a certain extent that we're founded in Canada, where we had a progressive regulator that allowed for the use of alternative technology, and so we do have a few projects that have been approved by the Alberta Energy Regulator, and we really think kind of designing those product or those programs has given us an edge as kind of regulations evolve in the US.
Okay. And then what are Qube's key strategic objectives, for 22, the rest of 22 and 23? So like when we sit here a year from now, how will we know that the company is making progress?
Yeah. Do you want to answer that, Eric?
No, go ahead, Alex.
Yeah, I was going to say, over the past year, we've probably grown from about 5 customers to around 40 to 50 now. And so really a lot of the focus now is supporting the pilots we've sold and making sure they turn into larger expansion deals. And we think over the coming months, we're going to have some kind of big public announcements here with some large operators in the US and around the world.
Okay, great. Well, last one for me, what's the big misperception about Qube and or the space you operate in?
Yeah, I think I don't know, maybe Alex and I have different opinions about this, but I think one common misconception is that more data is always better. I think with continuous monitoring, because when it first came out, it was very exciting because you never really had that at a cost-effective basis. But because you're recording data continuously, there's a lot of things to be churning through, and if you're looking at a bunch of different sensors, it's just a lot of data to sift through. Our focus and what we spend a lot of time on now is we think the long-term differentiator is going to be on the analytics. What actionable insights can you actually draw from all of this data? What kind of trends can you actually see in all of this data that you can actually help your operators, but not only operators, but industry kind of understand what is actually happening in emissions, what is the effectiveness of your repairs, how long do those repairs last for? And that's kind of what we're really focusing on the analytics piece now.
Got it. Well, any final thoughts, guys, before I let you go?
Oh, I just really enjoyed the questions in the chat. Thank you for the time, James. And thank you for having us on the podcast.
Yes, this has been fascinating. So good to catch up again and look forward to doing it again soon. And congratulations on your success.
Thank you.
Okay, take care, guys.
Bye.